In this video, we are going to discuss categorization of machine learning. Machine learning can be categorized mainly into three heads. The first one is the supervised, next one is the unsupervised, and the last one is the reinforcement. So we shall discuss one by one. Supervised learning. So supervised learning is task driven, labeled, and here we usually use the methods like regression, classification, and input variables x, and if the output variable is y, then y is equal to function of x. This algorithm learns from the training data set, iteratively make predictions which are corrected and through the teaching. And learning stops when the performance reaches to the certain acceptable level. So these are the features of supervised learning. So it is task driven. One task will be given to that model after being trained, and the task is supposed to get performed. That means the model will do some classification. That means some new data set will be given to the model after being trained, and then the model will do the classification of that given data, that is the task, or some regression will be there with the help of which it can predict some data. So in case of continuous data, we are having this regression. In case of discrete data, we will be having this classification. So that is known as the task driven. Now the question is coming, what is labeled? Why this particular data set will be called as labeled? So for this one, let us go for the next slide once. So this is our very famous Irish data set, and this Irish data set we have used in our multiple different examples in this tutorial in the implementation using Python. And this particular Irish data set, here I have put a part of that. It is having a long data set there. It is having attributes like your sepal length, sepal width, petal length, and petal width, and that is our species. So this is the respective sepal length, width, petal length, width are given, and these values are given, and it is classifying it as three different type of species. So that means this particular data set is having three classes. So one is the versicolor, this one is the setosa, and the last one is the virginica. So there are three different flowers are there, and their respective four attributes are given, and the species has been concluded. So that is our outcome, that is our classes. So how many classes this particular data set is having? Three classes. So as this outcome is also mentioned here, this outcome is mentioned, so that's why this data set will be known as the labeled data set. So that's why in the previous slide we had this one task driven we have discussed, and that's why it is called labeled. So supervised learning is labeled because this very particular fact, for certain attributes the outcome is given to us. So our model will be trained with this data set, and then a new data set will be given. That means the respective sepal length, sepal width, petal length, and petal width will be given, and then our model, which has been trained properly, will be predicting the target flower type. That is one of the classes of this versicolor, setosa, and virginica. Let us see another example. I think that will clear our doubts. So here you see we are having muffins and cupcakes, and these muffins and cupcakes we are having here. I have just put the pictures here for a better understanding. Here this is a long data set is given. What are they? They are nothing but describing the respective recipes for this muffin and cupcake. So these are the different ingredients which will be required. So flour, milk, sugar, butter, egg, baking powder, vanilla, and salt. So different proportions, the respective proportions are given, and then it is labeled that this particular recipe for this cupcake, this particular proportions are for this muffin. So my model will get trained, and then I shall give a different proportions, and then my model will tell using artificial intelligence that this recipe is either for muffin or for cupcake. So how many classes are you having here? Two classes are there, muffin and cupcake. So in this way, this output, this particular data set will be known as labeled. So that means we are having prior information and this information will be fed to the machine learning model. The model will be trained, and then we shall give some unseen input, and then the model will predict. This is known as supervised learning. So, input variables x and output variable y, then y will be is equal to function of x. Algorithm learns from the training data set, as I discussed earlier, iteratively make predictions which are corrected, that is the teaching. So, learning stops when the performance reaches to the acceptable level. So, now let us go for this unsupervised learning. Now, what is unsupervised learning? It is data driven, unlabeled. Here the method which we will be using is mainly the clustering, and no correct answers, no teacher, no labeling. Algorithm looks for patterns in the data. So, here we have written the main key points of this unsupervised learning. So, I think it would be better, let us go for one example that why it is called data driven and unlabeled. Now, see this particular data set for unsupervised learning. So, what is happening here? You see here we are having multiple different items: tea or coffee, sauces, confectionery, puddings and desserts, frozen, razor blades, and so many items are there. So, what are they? Actually, we are having multiple transactions, say in a shopping mall. So, these items are there, and in a particular shop rather, in these items are there, and we have considered different bills which have been made throughout the last 10 years. So, in that case, we are just putting 0 and 1 only to indicate that these items occurred in the same bill, and this another combination is there, only one item has been purchased frozen in another bill. In this we are having say crores of such data sets, we are having crores of such records in this data set. Now, I shall have to find out the pattern, that means which items are occurring very commonly in one bill. So, here you see there is no outcome, there is no teaching, there is no training, there is no labeled, it is data driven. So, it is known as unsupervised learning. Try to get my point. Here you see there is nothing outcome, no classes are there pre-given. So, what we are having a huge set of data, from where what we are trying to find out, say one particular pattern. What pattern? Which items are occurring very frequently in the billing process. So, in that case obviously, if we find that this item and that item has been sold very frequently in the same bill, then you can go for some, what should I say, some offer may be given to that, some combo offer of those two items, and where to place those two items, in which shelf, in which rack, where to place them and how to place them. So, we can do the business planning, and we can implement some planning for that. Strategy can be also implemented for that. So, this is known as data driven. So, data set for unsupervised learning. So, let me revise once again. This is known as unsupervised learning, that is data driven, unlabeled. Here we will be doing the clustering. Clustering means we are trying to find out the group of items which are having some similar properties, or which items are within a very small some predefined distances, within the predefined distances. So, in this way we can do the clustering, and then no correct answers, no teacher, no labeling. So, this particular data set will be given to our model. So, model will try to find out, will try to train itself, and will try to find out some pattern in our data. So, algorithm looks for patterns in data. So, that is our unsupervised learning. So, let me go for the reinforcement. So, that is a reward feedback based. Algorithm learns to react on an environment, automatically determine ideal behavior within a context. So, this is our reinforcement. Now, what is that actually? Let us suppose when we usually play a computer game, then most of the time we are having some idea. I have seen that some other person have played that game, I was with him or her, so I am having some idea. But when I am playing with that game, so initially I was failing to move to the next level of the game. So, what was happening? I was causing some mistakes, some faults were there in my playing, strategy was not good. So that's why I was missing to move to the next level. So from there I'm learning, and when I got my chance to move to the next level, each and every time I'm getting rewarded, and I'm making myself learning, I'm making myself learn that this is the way in which I should play. So this is known as the reinforcement learning. Let us suppose when a particular say kid is trying to learn that how to drive a cycle, so how to do the cycling, he or she might be having idea looking at some other people that we should paddle, we should hold this respectively handles and so on. So the mechanism must be known to them, but when they are learning, so they are getting this idea, sometimes they are falling, having some painful experiences. So from there they are getting this idea that what has to be done, what has not to be done. Sometimes the rewards are coming from the parents that you have done a good job, yes, you are now a perfect rider. So in those cases, getting the rewards, the kid is learning that how to do the cycling. So that is our reward feedback based. Algorithm learns to react on to an environment, automatically determine ideal behavior within a context. So in case of reinforcement learning, we are having two things. One is the agent, another one is the environment. So agent will give some input to the environment, and environment will give some feedback to the agent, and in this way the agent will learn from the environment. So this is our machine learning. So it can be categorized into three heads: supervised, unsupervised, and reinforcement. Now let us discuss the machine learning coordinates. So supervised learning, in case of on the discrete data, we will be going for classification or categorization, and in case of continuous data we will be going for regression. So in case of Irish data set, whatever we discussed, then you can go for the classification or categorization. The petal length and sepal length and width will be given to us, and then a new data set will be given to us on which we shall go for the predictions. So we can go for the classifications, and here in case of predicting something where we are having y is equal to function of x. So for a new x, I can calculate this value of y. So regression can be applied in case of continuous data. In case of unsupervised learning, in case of discrete, we will be going for clustering. Clustering, I told you this one, we are trying to find out similar data in a certain group or cluster having got either similar properties or having the distance within a certain limit. Another one is the dimensionality reduction. So question is coming in the mind that what is the dimensionality reduction? So in statistics, machine learning and the information theory, dimensionality reduction or dimension reduction is a process of reducing the number of random variables under the consideration by obtaining a set of principal variables, and it can be divided into feature selection and feature extraction. So this is our dimensionality reduction. Now the question is coming in the mind that what is our principal variables and what is our feature selection and feature extraction. So feature selection and feature extraction means that we know that feature selection means we are having multiple attributes in a data set. We shall try to find out those features which is actually related with the outcome. So we can select some of the features, because if you go on dealing with huge number of features and attributes in the data set, then obviously the computational complexity will be too high. So in that case we can go for the feature selection, and in case of feature extraction we will be going for secondary layer of some extraction from the data set. That means we are not going for the classification, but we are trying to find out some extra information from our data set. So we shall discuss them in the later slides. So we will be having the clear conception. So that is known as the dimensionality reduction. So at first we are discussing with this classification and clustering. So classification is the problem of identifying to which of a set of categories, also known as classes, a new observation belongs on the basis of a training set of data containing observations or instances whose category membership is known to us. So that is, just consider our Irish data set, just consider our muffing and cupcake data set. In those cases, we know the previous information because the data set was labeled. So now we shall try to predict on a new data set given to that. So classification is considered an instance of supervised learning and learning where a training set of correctly identified observations are available. The corresponding unsupervised procedure is known as clustering and involves grouping data into categories based on a measure of similarity or some distance. So we have discussed this one, that is a classification and clustering. So example, this is an example of classification problem where there are two classes, one is a low risk, another one is a high risk customers. So the information about a customer makes up the input to the classifier whose task is to assign the input to one of the two classes. After training with the past data, a classification rule learned may be of the form like this. Just consider this one. If income is greater than theta 1 and savings is greater than theta 2, then low risk, else high risk. So here we have plotted income along the x-axis, here we have plotted the savings along y-axis. Now what is income? What is the problem actually? Let us suppose a credit card company has got multiple crores of different applications have been made by the applicants. So all those application data is available. Now the credit card company will decide whether they will issue a credit card for the respective applicant or not, whether it is going for two classes, low risk credit card should be given and high risk credit card should not be allotted. So now you see when the income value is greater than theta 1 and the savings is greater than theta 2, just look at here. So theta 1 more than theta 1 and greater than theta 2, then that is our low risk zone. We have marked this one with some other color, otherwise it is our high risk zone. So that is the respective clustering we have done here. So now let us go for the next one. So in this way, the classification and the clustering, here we have done the classification, and whenever we are trying to find out some group of data, in that case having the similar properties or some within a distance, then we can go for the clustering in that case. So here we are having two classes, one is the low risk and another one is the high risk. Next one, we are going for the regression. So a regression problem is when the output variable is a real value such as dollars or say weight instead of a class. That means it is a numeric. Estimate the relationship between a dependent variable and one or more independent variables, also known as predictors. So here you can say that we are having the sales figure for a television model can depend on several factors. So that is the screen size, display type, brand, resolution, technology, etc. So that will decide the sales of that particular particular instrument. So now this television is having multiple different properties. So this instrument we are trying to find out that what is the respective sales prediction. So here we consider just one attribute, that is the screen size of the television, and plot the corresponding prices. So here we have plotted the screen size and here we have plotted the respective sales figure. And here we are having the screen size we have plotted and plot the corresponding prices, that is x is equal to screen size and y is equal to sales figure. So we try to find the relation function that best matches these two values. So here we have plotted the screen size, here we have plotted the prices, means actually you are trying to mean that one as the sales figures. So now here we are having multiple dots and we are suggesting one line that is known as the regression line, and this is the respective equation for the regression line. So for some unknown x, I can find the respective y value. So y is equal to f of x. Next one we are going to discuss, that is the dimensionality reduction. So dimensionality reduction is a process of reducing the number of random variables under consideration by obtaining a set of principal variables. So it can be divided into feature selection and feature extraction. So that is known as the dimensionality reduction. A data set may have hundreds of attributes, thousands of attributes. If I go on doing calculations and learning process with all those attributes, then obviously the computational complexity will be unnecessarily high. So in those cases, we should select those attributes which are the prime attributes, also known as the principal attributes, on which we will be training our model, and later we shall expect a good prediction out of them. So this is known as the dimensionality reduction. So next we are going for the feature selection. Feature selection approaches try to find a subset of the original variables, also called the features or attributes. It is about choosing some of the features based on some statistical score. So we might be having multiple different features. So we can make those features with some weightage values. So that those features with the weightage value smaller, that means that feature is having lesser importance. And those features which are having the weightage value higher, that means that feature is having the higher importance. So in this way, we can go for this feature selection. Next one is the feature extraction. So feature extraction transforms the data in the high dimensional space to a space of fewer dimensions. It is using techniques to extract some second layer information from the data. So as example, you just see this one, interesting frequencies of a signal using Fourier transform. So if we find this particular one, so you are going for a second layer of, that is a second layer of information you are trying to find out, and that is known as feature extraction. So the data set is actually meant for something, but we are trying to find out something new from that one, from that particular data set. We are trying to predict something new or calculate something new, and that is known as feature extraction. Dimensionality reduction helps in data compression, reduces computational time, and removes the redundant features. So in this way, we have discussed all these respective categories and different classifications, clustering, categorization, dimensionality reductions, everything we have discussed into details. Please watch all the videos in the tutorial for your better understanding. Thanks for watching this video.